So, we shall continue with the nuclear and particle physics. We will be discussing about the radioactive series. Already we started in that, and then the naturally occurring radioactive series fall under category A equal to 4n, 4n plus 1, 4n plus 2, 4n plus 3. We were just started discussed about 4n. We will continue with 4n plus 1 and other series, and we will be discussing about the laws of radioactivity, and we derive an expression for a decay constant and for mean life, half life. The naturally occurring elements or the radioactive elements in nature fall under 4 categories with the mass number A equal to 4n, 4n plus 1, 4n plus 2 and 4n plus 3. So, we will continue with the 4n plus 1 series. So, here A equal to 4n, A is the mass number and n is an integer. All the series in the naturally occurring elements, all these elements in the series, for example, plutonium 241, if you divide by 4, I will be getting remainder 1. That is what we see, 241 divide by 4, I will be getting remainder 1. So, it is called 4n plus 1 series. This plutonium is not stable. It emits alpha particle, and we know that alpha particle emission, the mass number will be changing by 4 units from 241 to 237. And then we have got atomic number changes from 94 to 92. Again, if you see 237, if you divide by 4, there is remainder 1. So, all in the naturally occurring series, all of them will be having only A equal to 4n plus 1. Uranium is again not stable, it emits neptunium 237, and here because it is beta minus emission, from 92 it goes to 93. Then again it goes to Pa. Now, when you go to Pa, the series Pa is again is not stable, that goes on, it goes on. The whole list we need not discuss here, it is only for the idea we are giving. If we go through the periodic tables or Clark's table, if you go through, you will be getting all the elements, and what is more important is the last element, bismuth. So, all the other elements were unstable, but when we come to bismuth 83209, it becomes very stable, and it has got n equal to 126 neutron number. See, namely 209 is the mass number, 83 is the atomic number. So, if we subtract, I will be getting 126. So, when n equal to 126, it becomes stable, because they did not know what is happening. This was in the shell model, we have explanation for this, but this was analyzed much before the shell model. Therefore, they did not know the reason why it is stable. Whenever this number n equal to 126, it becomes stable. It was called a magic number, because it was not in the scope of understanding, it was called magic number. Now, we will go to the 4n plus 2 series. So, here as we said, n is an integer. Here all the mass number will be, if you divide by 4, you will have remainder 2, 238. If you divide by 4, I will be getting 236 and then remainder 2. This is uranium 92-238, and it emits alpha particle, and daughter nucleus will be thorium, thorium 90-234. So, here the mass number changes by 4 and atomic number changes by 2 units, and this again 234, if you divide by 4, I will be getting remainder 2. So, this goes on till we get last one, lead, Pb 82-206. Here again this 206, if you see, if you divide by 4, I will be getting remainder 2. So, it is called, it is falling under 4n plus 2 series, and this is very stable. Here Z equal to 82, Z equal to 82. Whenever Z equal to 82, that particular element, namely lead, is a stable element. See, the lead is very stable, that is why we are using lead in a nuclear reactor for shielding the radiation. In a nuclear fission reactor, we get alpha, beta, gamma radiations coming. that should not affect the environment. So, they are kept in a lead chamber. And not only that, even in hospitals where we have radiation for therapeutic purpose and diagnostic purpose, it is always kept in the lead chamber, so that it will not the radiation will not enter the environment. And why it is used? Because it is stable, it is not able to emit anything. All other elements were emitting, but lead is stable, it does not emit any of the radiation particles like alpha, beta, gamma. And again, because Z equal to 82 was found to be stable and it was outside the scope of understanding of the shell model, it was called magic number. So, Z is called, some magic is happening, they said it is a magic number. Now that magic number is understood, we know how it is, but we just use the conventional terminology, namely magic number. Now, we will go to the next one, the last of the series, A equal to 4n plus 3. So, in nature, again as we said, if you have a radioactive rock, if you take a radioactive rock, either it will have all the elements in A equal to 4n, A equal to 4n plus 1, A equal to 4n plus 2, or A equal to 4n plus 3. And this one 4n plus 3, as we see, this is starting is uranium 235. That mass number 235, if you divide by 4, I will be getting remainder 3, and the daughter element is 231. Then again it has got remainder 3. Therefore, all this uranium 235, thorium 231 and all other, these are all coming under 4n plus 3 series. And again, what will be the last one? It will be 82207, lead, that is lead 82207 Pb, it must be Pb 82207. What we say is Z equal to 82. Therefore, this Z equal to 82 is said to be magic number. In that 4n series, we have the end of series was Z equal to 82 and n equal to 126. That is actually the last element will be lead 82208. So, we found that in the 4 series, naturally occurring series, they observed that whenever Z equal to 80, whenever Z equal to 82 or n equal to 126, that particular element is very stable and it is not emitting any alpha, beta, gamma radiation. So, this 82 and 126 were called magic numbers, because when we do not understand how it is happening, we think it is a magic. Once we understand, it becomes scientific. It was called magic because it was outside the scope of liquid drop model. This first model which came is liquid drop model, LDM, that is a classical model, and there is no closure effect, that is, there is no shell structure at all. So, the whole nucleus is considered to be like a liquid. Then we can't understand why these certain numbers are stable. So, outside the scope of liquid drop model, the shell model will explain the magic numbers. So, later on we will be discussing the shell model of the nucleus. There we will find that the shell model is very similar to what we have in the atomic case. The atomic case, we have the electrons filled up, and whenever the electron is filled up, that particular element is stable, and we have got the electrons filling up in K, Lm shells. Similarly, we have got nuclear case, there is a shell occurring, and this shell is not by electrons, it is by filled up by neutrons and protons. We have got the 4 series we said, 4n plus 1, 4n plus 2, 4n plus 3. All the series, if you take a radioactive rock, you will find all the series available, and we find that this 4n is missing series. It is only predicted, it is a missing series. Why it is missing? We have 4n, when you have 4n plus 2, 4n plus 3, there must be 4n plus 1 also available. Therefore, we are only predicting, and we find that why it is missing, why we do not get 4n plus 1. The mean life of members, that is in the 4n plus 1, we have got plutonium, then uranium 237, neptunium, all these elements have got lifetime shorter than age of the earth. shorter than age of the earth. Therefore, when the earth was created, these elements would have 4n plus 1 series would have been there. Now, after so many years, all of them have vanished. They have become, all of them have become bismuth now. All these elements have become bismuth. Bismuth 83209, that is the stable one. These things are all not available because their half-life or their life is shorter than the present age of the earth. See, yeah? That is what we have just mentioned here. The mean life of the members of 4n plus 1 series like plutonium, neptunium are shorter than the age of the earth. Age of the earth is about 10 power 9 years, whereas all these elements have got 10 power 6 years. Lifetime is 10 power 6 years. This is 10 power 9 years, age of the earth. Therefore, they would have vanished much earlier. So, now when you say 4n plus 1 series, when you artificially produce, you must be able to get that, and they have done. The artificial production of plutonium 241. Why do you go to 241? 94 241. So, I will go back to this 4n plus 1. First element is 94 241, which is not existing in nature because its lifetime is shorter than age of the earth. But however, in a nuclear reactor, in bombardment reactions, it can be produced. So, they have just produced this and they found that it is able to give all these elements, namely plutonium 241 gives a daughter uranium 237, and then you get neptunium. Neptunium is also a missing series because all of them have got a shorter life. Then Pa, all this. So, they are able to reproduce all this from artificial bombardment. So, the artificial production of Pu 241 reproduces 4n plus 1 series, and here the life is 10 power 6 years. All the elements we consider, that is the longest one. Some of them are much smaller. Transuranic elements do not exist in nature. Say, when you say transuranic, uranium has got atomic number 92. So, anything more than, like example, neptunium 93 and then plutonium 94, those things do not exist in nature. For example, this one is a transuranic element. Neptunium 93 is also transuranic. Uranium has got Z equal to 92. Up to that, we have a provision in nature. Nature is able to exhibit these nuclides. More than that, they do not exist, but they can be produced by artificial means. So, they are called transuranic elements, after uranium, transuranic elements. We talked about the radioactive series. Now, what is the law of radioactivity? We find that any natural decay is exponential. See, for example, you would have studied in electricity subjects. If you charge a capacitor, it will exponentially charge, it will take some time, and then it will mature, saturate and charge. Even if you put a cell phone charger, maybe it will take 10 minutes. First, initially the charging will be larger, after that it will saturate, and after that there will not be any more charging. If you keep it for 1 hour, there is not going to be extra charge. First 10 minutes there will be large charge, and then it will become exponential. Exponential is, it goes this way, exponential. So, it saturates, it is not linear, exponential. Any natural decay is also exponential. When you say decay, it is this way, charging is this way. So, we get charging or discharging of a capacitor is exponential. So, any charging and discharging will become even a battery, it is charging is also exponential, discharging also exponential. And one interesting thing is, even air growth is exponential. Suppose you cut your hair, first day maybe the growth will be 1 millimeter, let me say 1 millimeter. Next day it will not be 2 millimeters. Next day it may be 0.9 millimeter. Third day it may be 0.7 millimeter. And then maybe after a month it will be 0.1 millimeter, then 0.01 millimeter. After that the growth will stop. If it is linear, anyone who cuts the hair will be every day it will be longer and longer, but that does not happen. So, it first grows initially very fast, and then it saturates. So, the air growth is exponential. Similarly, you will find that curing of a building is also exponential. If you have put the cement, all that, they just maybe they say 21 days. That is, after that it does not mean completely cured. It will cure and it will saturate. So, the curing first initially maybe in 1 or 2 days the curing will be faster, and then it will stabilize. So, the curing of a building is also exponential, and also the growth of a plant, as we said here, growth of a plant, maybe it will shoot. If you put a seed, it will shoot up, and then slowly maybe every day you will find 1 or 2 1 centimeter, 2 centimeter maybe, then finally you will find that the tree goes to a height and then stops. It does not linearly go on, it does not go on like that. Even the growth of a plant is exponential, and even healing of a wound is e power x, I have written as e power x. Healing of wound is also exponential. So, if you make a cut, it will heal. After maybe 21 days the bone, if you got a fracture, it will heal very fast initially. After 21 days the healing will be complete, and the complete healing will maybe take even years. So, the healing is also exponential. So, generally we find that all natural phenomena are exponential. This was observed by nature, has given this was observed by Napier, and he only found out this base, natural base E equal to 2.71828. That base, we know that natural logarithm, then log to the base 10. When you take natural logarithm, it is this base e power 2.7. That is the base of natural logarithm. And why, when all these things are we see, like growth of hair, healing of all this we see, they are all exponential following this e power x rule. Therefore, the radioactivity, what we do not see inside a nucleus, that should also be exponential. That is why we get the exponential law. So, the law of radioactivity is also expected to be exponential, and it is true, exponentially found also. So, we write the exponential law now. Now, here this is a decay phenomenon, it is not a growth phenomenon, it is a decay phenomenon. Therefore, we just write n equal to n0 e power minus lambda t. What is n now? N is the number of nuclei at time t. N0 is the number of nuclei at time t equal to 0, and this lambda we called as decay constant. So, we get, as see here in this equation, as time increases, e power minus that quantity goes on increasing. Finally, when the t goes to infinity, it will become 0. So, only when it goes to infinity, the number of nuclei will completely become 0. And when you take at time t equal to 0, if you put time t equal to 0, e power minus lambda t, so t equal to 0, I will be getting n equal to n0. So, that is the maximum number available. So, this proportionality constant, here we get e power minus lambda t, and e power, that quantity must be a dimensionless quantity. So, the t is second. So, lambda will be 1 by second. So, that e power lambda into t will be a dimensionless quantity. And here if you differentiate that, I will be getting dn by dt. Why do you differentiate? I want to know what is the rate at which the nuclei are coming out. So, n is the number of nuclei available. So, dn by dt will be number of nuclei which are disintegrating, number that is loose, coming out or decaying. So, if you differentiate that, I will be getting minus n0 lambda e power minus lambda t. So, I have just differentiated equation 1, and then I can put dn by dt equal to minus lambda n, because see this already we have got this expression n0 e power minus lambda t is n from equation 1. Therefore, if we put that here, I will be getting dn by dt equal to minus lambda n. That is what you have written here. And this dn by dt equal to minus lambda n is called activity. Dn by dt is called activity. So, how active is the nucleus? So, the dn by dt will decide. Suppose dn by dt is 0, then it means there is no activity, there is no change in number of nuclei. So, the dn by dt decides the activity, and that will depend on the number of nuclei which are present and also the decay constant, because for each nuclei the decay constant will be different. And why we get this negative sign? Because it is decrease in number. As time passes, the number of nuclei decreases, therefore we get a negative sign. So we are just rewriting that, and we can write lambda is equal to minus dn by n. This is dn by n by 1 by dt. See, this must be minus dn by n 1 by dt. So what is that dn by n represents? It represents the probability. So we will go to the next one. It represents the probability of decay per second. Probability is favorable chance by total number of chance. So this dn is the favorable number of nuclei which will come out. Minus dn represents the favorable number of nuclei which will come out by n. N is the total number of nuclei. So it is favorable chance by total number of chance. So this part represents probability, and this represents time. Therefore lambda will represent probability of decay per second. So that's what we have just said. Decay constant lambda is probability of decay per second. So this is the probability of decay per second. So what will be one inverse of that? So that will be the time taken for decay. Lambda is probability of decay per second. So 1 by lambda will be time taken for decay. That we call it as mean life. That is mean life of the nucleus. So the mean life we can write 1 by lambda is equal to tau. So that is the mean life expression. And when you say half-life, so the mean life is how long this nuclei can or the radioactive element can live, how long it will take for emitting all the atoms or all the nuclei. Half-life, when you say half-life, it is the time taken for the nuclei to become half in number. So that is the time taken for the nuclei to become half in number. Say suppose you are given 1000 rupees. How long will you take to make it 500 rupees? That is called half-life. You are given 1000 rupees. How many days you will take to make it 500 rupees? And how long you will take to make it from 500 to 250 rupees? Similarly, the total number of nuclei is n, maybe 1 lakh nuclei. What will be the time taken for that 1 lakh nuclei to become 50,000 nuclei? So that is called half-life. Or the 50,000 nuclei to become 25,000 nuclei. So that is called half-life. So therefore this half-life will be able to, we have to just see where we get half. So what we do, n by n0 equal to this, I am just rewriting and we are getting this part. Now this t I can just put as t of and we get this expression. So we will come back to this again, summarize what we have studied, and we will come back to mean half-life again. So summary, what we have discussed is natural decay is exponential. We have seen, and for us to understand the nature, we said about the hair growth or healing of a wound, all of them are, it is exponential. And what is activity of a nucleus? We said its activity is dn by dt is the activity of a nucleus. And what is the meaning of decay constant? When you say decay constant, it is nothing but probability of decay per second. Mean life, and what is the probable life it can live, and what is half-life, the time required to make the nuclei half in number. And we are yet to come to total probability and branching ratio. I will just put a few questions. Why is alpha particle very stable? It has got 2 proton and 2 neutron. Therefore they will couple antiparallelly and it will be stable. Why is beta termed isobaric transition? The word, as we said, when you say isobaric, A equal to constant. So in a beta decay, A is constant. Mention the 4 radioactive series in nature. So always you remember we have got 4n plus 1, and we have already discussed the 4n plus 1 series, why it is missing. Show that the decay constant is probability of decay per unit time. How are mean life and half-life related? So obtain the expression for half-life of decay. And what is branching ratio? Thank you.